For the first problem, determine whether the ordered pairs are a solution to the system. So we have the two equations. We have two ordered pairs that we're going to be testing. So first, let's test the ordered pair -2, -1. We're going to plug -2 in place of x, and 2 times -1, put -1 in place of y. Oops, we have to see if that equals -4. Does -2 plus -2 equal -4? Yes, it does. So it works for the first equation. Now we have to check it for the second equation. 2 times -2 plus -1, is that going to equal +4? No, that's going to equal -5. Because this ordered pair doesn't work for both equations, it is not a solution. Then we can check the point -4. Top equation, put 4 in place of x, put -4 in place of y. 4 plus -8, yes, that's going to equal -4. Try it in the second equation. That would be 8 plus a -4. Yes, that would equal 4. So this one is a solution. This time we have a system of inequalities and we have 3 ordered pairs. So I'm going to start with the ordered pair 4, 5. And we need to test to see if when we put 4 in place of x and 5 in place of y, if these inequalities are true. So if I plug 4 in place of x, 5 in place of y, is 4 plus 5 larger than 5?
Yes.
Yes. So we're good for the first inequality. Then plug it into the second one. 4 minus 3 times 5. We need to check if that is smaller than 0. 4 minus 15, that's going to be a negative number. So yes, that's going to be smaller than 0. That one is a solution. Take a moment on your own and try 3, -1 and 0, 5 and see if either of those work. For the point 3, -1, I plugged it into the first inequality. 3 plus a -1 is not bigger than 5. That's not true. So it's not a solution. If you get a no on the first inequality, don't waste your time with the second. If it doesn't work for the first one, it's not a solution. Then I tried 0, 5. 0 plus 5. Is that bigger than 5? No, it's not or equal to. It says greater than. So that one is also not a solution. On the test, this problem will look very, very similar. One of the equations will be either a horizontal or a vertical line. So that one should be fairly easy to graph quickly. The other one is going to require you to do probably one step to get it ready to graph. So what do we need to do to this equation? Add 3x. So y equals 3x minus 1. We start at -1, up 3, right 1. And it conveniently, your slope takes you straight to that intersection point. They intersect at the point 1, 2. After you graph these in EdCite, don't forget to keep scrolling down and enter that point where those two equations meet. This is our first solving systems problem, and you'll notice the difference between this problem and the others is that infinitely many solutions and no solutions are an option, which means if we read between the lines that one of those is probably going to be correct. You could do this doing substitution or elimination. Personally, I prefer elimination, and I see that I've got positive 3y. So I'm going to multiply the top by -3. That will give me -3x plus -3y equals -6. My original bottom equation. And as you're writing them, you might already see, wait a minute, these are exact opposites of each other. So when we solve this, when we add them together, we're going to have 0 plus 0 equals 0. Does 0 equal 0? That means many solutions. If you got something like 0 plus 0 equals 12, that is not true. That would mean that your answer was no solutions. And hint, hint, wink, wink, because it was infinitely many solutions on the practice test, there's a chance it's no solutions on the test. Hint, hint, wink, wink. This one is perfectly set up for substitution. X equals 4y plus 19, so we're going to put that in place of that x. So 5, instead of the x, we'll do parentheses 4y plus 19, and then continue with minus 3y equals 10. We distribute. 19 times 5 is 95, by the way. Combine like terms. And then solve, figure out what y is. Once we know that y is -5, how do we find x? Plug it in. 4 times -5 plus 19. So -20 plus 19 is -1. The next system is honestly set up the best for elimination. It's the type of elimination problem where you're going to have to multiply both of them. So look at your x's and your y's. X's, our goal is going to be 10x and -10x. For the y's, 12y or -12y. Do you want to go for 10 or go for 12? 10? If we're going for 10, we would multiply the top equation by 2 and the bottom equation by -5. Remember, our goal would be to have 10x on the top and -10x on the bottom. So if we do this, we would have 10x plus 8y equals 4. For the bottom equation, -10x minus 15y equals -25. Pause the video, finish solving this on your own, and then play the video. I'll go through it super fast. So when we add these together, these cancel. We've got -7y equals -21, which means y is -3. +3. You know, one of those. Most common error on these is losing a negative or sticking a negative in where it doesn't belong. Glad I have someone watching out for me. Then 2x plus 3 times our y, which is 3. So 2x equals -4, which means x is -2. I always prefer elimination. I feel like it's less work. If you prefer substitution, all you would have to do is subtract this 2x on both sides, and you would have y equals -2x plus 5. You could then substitute that in place of the y in your second equation. The only thing with substitution is you have to remember, if you rearrange the first equation, you have to substitute that into the second equation. You can't substitute an equation into itself. And I think that's the reason why I don't like substitution personally. So I would multiply the top one by -2 so that I have -2y on my top equation and +2y on my bottom equation. So negative 1x equals, oops, I am making all kinds of mistakes here. I forgot to distribute that negative 2 to the 5. So that would be a negative 10 on the right side. X equals 9. And then plug that back in to get your y value. I will give you a reassurance right now that this word problem is identical to the word problem on the test, except that there's a different number of hats and shirts and different cost. So you are going to have to do this problem. You can't just memorize it and then regurgitate it. However, the first sentence is one equation, and the second sentence is the second equation. So a lot of the examples we did, you had to like hunt through the entire problem to find the things that matched. This one's really nice because first sentence is first equation, second sentence is second equation, and then you're done. So 4 shirts, 4x, plus 5 hats, 5y, equals $88. So 4 times the cost of the shirts plus 5 times the cost of the hats equals $88. That's the first equation. Your second equation is 2x plus 2y equals 40. To solve this system, personally, I would do elimination. What do I need to multiply the bottom by to do elimination? So we have negative 4x. Let's see if I can do this correctly this time. And our original top equation.
You just take negative 4y, the plus out of negative 4y, and just do
8. The other thing that you need to keep track of is what x and y are. So x are your shirts, y are your hats. I just figured out that the hats are $8. Then pick an equation to plug that back into to figure out the cost of your shirts.